Niklas, for that challenge. It's a great challenge, obviously, but also an opportunity. If we now talk about where can a designer make a difference when it comes to the environment. If you first think about it, what first comes to mind is the effect of aerodynamics. And you should know that it is an exponential to the speed that you're driving. So the way people are driving here in Germany on the Autobahn, the effect of aerodynamics are very important. And the majority of the energy consumed by the car is used to overcome this wind resistance. But obviously, the traffic is not flowing perfectly smoothly every day, and a lot of times we're driving very slowly in traffic situations, in the city, for instance. And then aerodynamics has little or no effect on the fuel consumption. I think you, in the sports goods industry, have a good understanding of this effect. Just look at the difference between one of these time trial bicycles and a mountain bike. Every detail has been optimized on this car and designed to have a minimal wind resistance. Even the spokes are flattened to be just a little bit more narrower and more efficient. Or why not looking at this very extreme suit being put on a person who's trying to break the speed record in downhill skiing. We know that that suit is probably not the most comfortable or convenient, but for cutting through the air, it is very efficient. And we just have to remember that this is maybe not for everyone, because we know that most people are just wanted to go out into the snow and have some fun. But the optimal shape for wind resistance is the teardrop. But if we should apply this to the cars, it's quite a difficult shape actually to put wheels on and maybe people inside, but not for the lack of trying. Back in 1914, this car was created by Alfa Romeo. It was specially made for someone called Count Ricotti. I don't think there's any relations with the cheese, but I'm not sure. And the aim with this was, like for the bicycle and the downhill speed skier, to achieve higher top speeds with really no interest for the environment in this case. Unfortunately, this was a failure because the weight of this body was so high, so this car is actually a lot slower than the standard car. But at least they tried. And this knowledge and understanding of aerodynamics developed through the years, but most applications were more sort of superficial and styling driven. Like these tail fins that we saw on a lot of cars back in the 50s. They were there to sort of remind people, hoping to get a little bit of that glory from the jet engines and the space age at the time. But when it comes to actual real aerodynamic efficiency, they're useless. Actually, it wasn't until the early 80s that aerodynamics, the focus on aerodynamics turned towards fuel consumption. At VOLVO, we had our own wind tunnel actually already back in the 1970s, but maybe looking at the cars, we can maybe find that hard to believe. But the thing here is that during the development of this, we find out quite interestingly that sometimes it can actually be quite hard to just look at the car and just with your eyes determine if it's an efficient car from an aerodynamic point of view. I actually heard from some of the designers working back then that they actually put this car into the wind tunnel as well. And they were quite surprised to see that the Volvo was better. But we actually gave Porsche another chance because we turned it backwards into the wind tunnel just for fun, and then it performed better. So it's kind of interesting how this develops, and we have learned quite a lot in the last 20 or 30 years around this. And of course, depending on the car and the traffic situation you are using the car in, the effects of aerodynamics will be different, of course. But that doesn't mean that a slippery car will always be better for the environment. And as the science develops, and like you can see on the speed skier here, we are actually now getting back to new attempts to using that teardrop shape again. And this is the Volvo 3cc, which was a concept car that we showed a few years ago.
Stefan, that car was really, really cool. But the next big thing that's going to happen are the impact of material choices. Here we're going to have to consider the complete cycle of material from manufacturing to eventual recyclability. At Volvo, we've always put focus on this, but today we're probably quite proud of our achievements, right?
Yeah, I mean, absolutely, Jonathan. I mean, you're so right about this with the material choice, and that really is the second big aspect around this. But what really can make a difference is that the material you choose can have a great impact on the total weight of the car. And since they are moving objects, that weight has a direct relationship to the energy use. So if we're able to lower the weight of the car, it will reduce the negative impact on the environment. And as you can see here, we've done some extreme test cars for the future using carbon fiber and other high-tech materials. The total weight of this car was actually just 10 kilos. But then again, it doesn't have any powertrain or hardly anything else for that matter. But if we now take this aerodynamic effect and the material choice and then use them and look upon them more as opportunities, my last point in this is that also the eventual introduction of new powertrain technologies will give us even more new opportunities. And here we come to the part on the C30 recharge concept that Niklas talked about. He said that the electric motors are hidden inside the wheels here, basically taking no space at all. But that particular car had a conventional position and size of that combustion engine, but that engine is only there to recharge the batteries. You can basically put it anywhere in the car. And also then, if we consider what Niklas talked about, our ambition to create cars that will never be involved in accidents, we can even reconsider the whole structure of the car. We can basically have the possibility to change the whole rule book for how a car looks. Jonathan, isn't that exciting, huh?
Yeah, you know it is. Okay.
How would you do this on the interior?
I told you there was a technical issue. Okay.